In this video, we're going to introduce linear equations involving two variables. What is a linear equation in two variables? A linear equation in two variables is an equation with two variables, usually x and y, where the highest exponent on either variable is 1. Here are a couple of examples. 2x plus 5y equals 10, y equals 4x plus 6, and then y minus 5 equals 1/2 times the quantity of x plus 9. The solutions to these equations are written in pairs, ordered pairs specifically. There are always infinitely many ordered pairs for any individual linear equation in two variables. On the side here, in the graph, is a linear equation in two variables, although the one variable value doesn't matter. Notice how x is constantly 3, 1, 2, 3. But if I were to write this as x plus 0y equals 3, then I have a linear equation where both exponents are no higher than 1 for the two variables. All the ordered pairs that make this equation true is what's graphed on here. So those solutions, I was supposed to highlight that. There we go. Those solutions are going to be ordered pairs. Those ordered pairs, if you recall from geometry, they are written in terms of x, y, where x is my input and y is my output. Now let's look at a better graphical representation of a linear equation in two variables. Let's suppose we have this one, y equals -4/3 x plus 3. The line that is shown here is made up of all the ordered pairs that, when plugged into the equation, we have a true statement. Remember that the solution from the previous videos and previous lessons is simply a value that makes an equation true. Because there are two variables, there are infinitely many pairings of numbers that will make this equation true, which is why we have this graphical representation of the solution set. Here we could say that the line is the solution set. Every single ordered pair is a solution to this equation. All linear equations have a slope and a y-intercept. The slope, by definition, is the incline. The slope, by definition, is the incline or decline of the line, while the y-intercept is the ordered pair that crosses the y-axis. So if we were to look on this graph, the y-intercept would be right here, which would be the ordered pair 0, 3. This is my y-intercept. And now if we look at the slope, it would be the amount of incline. In this case, it would be how much it's going down. That's really bright. Let's change that to blue. No, blue. There we go. What we're looking at for slope is going to be some relationship here, because the change of height and the change of how it's going right to left affects the slope or the incline of the line. So let's look at slopes in particular. The slope of the line is the amount of incline or decline. This is also known as rise over run. This is something you've probably heard before. Okay. In a linear equation, the slope is always constant. We're given a formula here that helps you calculate slope. As long as you know two ordered pairs from the line, or if you know two solutions to the equation, you can find the slope. Let's suppose we look at the graph we have here. let's look at two ordered pairs that we can clearly determine. For example, I know we have that ordered pair there, and if I look again, looks like right here is where it also crosses. Those two ordered pairs are as follows. We have the ordered pair 0, 3, and we have the ordered pair 5, negative 1. If I want to find the slope, then by using the formula, I'm going to take the y value from one ordered pair, and I'm going to subtract the y value from the second ordered pair. And then I'm going to divide that by the x value of the first ordered pair minus x value of the second ordered pair. We'll get negative 4 over 5, and that right there is the slope. If we look at the graph, we see that we decline a negative 4 while we increase along 5. And here's where we get our two numbers. Negative 4 and 5. What we're going to do is we're going to find the slope, the y-intercept, and the x-intercept. The x-intercept is simply the ordered pair where the line or the graph crosses the x-axis. What I have here is I have the equation as well as the graph. So we can confirm what the slope, y-intercept, and x-intercept are from the graph. We're not always going to have the graph, but we can always find the answers algebraically. So if I want to find this y-intercept, it's always in the form of 0, b, where b is some number. But the x value is always 0. So I'm going to replace the x with 0, and then I'm going to solve for y. So 0, or 5 times 0, oops, make that a little better. There we go. Times 0 minus 4 times 0, or 4 times y, equals 20. This implies that I'm going to have y equals negative 5. Now we can see here on our graph that right there is the ordered pair 0, negative 5. If I want to find the x-intercept, this is always in the form of AB, where A is some number, and 0 is always set. So here, I'm going to let the y be 0. So 5 times x minus 4 times 0 is 20. That implies that x is 4. If we look here on the graph, we have the ordered pair 4, 0. The y-intercept is the ordered pair 0, negative 5, and the x-intercept is the ordered pair 4, 0. Please note that if we're asking for the intercepts, they are ordered pairs, not values. The last thing we want to look at is slope. Now, although slope was listed first on our solving list, it's actually the last one we want to find. Because in order for us to find slope without knowing the graph, we need to know two ordered pairs. And what we have are two ordered pairs. So my slope is going to be equal to negative 5 minus 4, or 0 over 0 minus 4. You should note that this is one of the ordered pairs, and that this one is the other ordered pair. And then we're going to have negative 5 minus negative 4, which is 5/4. Now we can confirm that by looking at the graph. if we were to draw these two, we see that from the y-intercept, we went up 5 units, and we went to the right 4 units, 5 over 4.